Just like Windows has dynamic link libraries, DLLs, Eantime provides real-time shared libraries, RSLs. RSLs serve the same purpose as DLLs, but there are some minor differences in the implementation. It is quite common that the same code ends up in more than one application. Usually such code is then collected in a library and linked with each application that needs one or more of the functions. In this way the source and object code needs to be maintained in one place only. But when some of this code changes, all applications that use such code must be rebuilt. When thinking about sharing code, it is logical to imagine sharing data as well. A real-time shared library, RSL, is like a static library, but it has an additional function. Whenever a process loads the RSL, a thread is created or deleted or the process stops using the RSL, the function RSL main in the RSL is called. This allows for process and thread specific initialization and cleaning up. To make it easy to start an RSL project, the Eantime RSL wizard can be used. RSL main is called in various places. When a process starts using an RSL, RSL main is called with the process attach reason. In this case, RSL main is not called again with a thread attach reason. If RSL main returns false, the process is aborted. When a new thread is created, RSL main is called with the thread attach reason. When a thread deletes itself, RSL main is called with the thread detach reason. When a process stops using an RSL, RSL main is called with the process detach reason. An RSL is loaded automatically at process loading time, when the process was linked with the RSL's import library, produced automatically in an RSL project. This is called static loading. It is also possible to postpone loading an RSL until the process needs it. This is called dynamic loading and requires some extra code. When an RSL must be loaded and the RSL name is not fully qualified, the loader looks in these locations in this order: the directory from which the process was loaded. Additional paths if defined. For Eantime for Windows, configured in the Node Management applet of the Eantime configuration utility. System table, value RSL search path, registry key h-key _ local _ machine /software /wow6432 node /tnesys /eantime /redaploader /rsl path. For Eantime distributed RTOS, the loader uses the values defined in the path environment variable. The directory is %eantime %bin/. Sharing data between processes that use the same RSL requires some extra source lines as indicated above. This is the same as for Windows DLLs. Note that currently Eantime does not share the RSL code in memory between processes. Todo Quisling, verify that Eantime still does not share the RSL code in memory between processes. Making common code available to applications in a RSL, thus avoiding to link this code statically and individually to the applications, already is a valuable benefit of a RSL. Thread Local Storage, TLS, is a Windows feature that comes in quite handy for DLLs. Eantime provides the same functionality for RSLs. If an RSL needs data that is specific for a process, all it needs to do is to export one or more variables. But what if it needs data for each thread? TLS provides the answer. This is how it works. TLS is an array of 32-bit fields allocated for each thread Indiana a process. An RSL allocates an index in this array for use in the current process. For every new thread, the TLS value with that index is initialized. At thread detach, the TSL value with that index is released, if any dynamic memory had been allocated. When a new process starts, a TLS index is allocated and kept in a global variable of the RSL, need not be shared with other processes. This reserves a 32-bit entry in a TLS table for each thread in this process. When a new thread is attached, its entry in the TLS table is filled with a pointer to some allocated workspace. Whenever the thread local storage is needed, RTTLS getValue returns the value of the TSL entry, which points to the workspace. When a thread is detached, its workspace is released. When a process is detached, free the TLS index. The above code reserves a new TLS index at process attach and frees that index at process detach. When a new thread is created, and also when the process attaches, a new instance of RSLB is allocated and the pointer is saved in TLS. A file name is then set up and a file is created. At thread detaching, the file is closed and the RSLB instance is freed.